In today's lesson, we're going to be looking into complex fractions. In the description box, what I'll do, I'll leave links to two videos, one for factorization and another video for general fractions, how to deal with fractions when multiplying them, adding them, subtracting them, and dividing them. So complex fractions, I just wanted to discuss them in isolation. I just wanted to have a discussion like Yama complex fractions on their own because they are somewhat special. So what is so special about complex fractions is that it's it's basically a fraction within a fraction, right? So uwahandlisha a little bit different from any other fraction, right? So Tina, we are used to this type of fraction, x minus 2, an algebraic fraction, maybe 2, like this. You have a numerator, a denominator, maybe being added to another fraction like this, 3x. Then you have to simplify, right? Complex fractions, they are somewhat the same, but then you're gonna have a fraction within that fraction, within that fraction. So in this instance, you know what? Let's define what it is. It's also called a compound fraction, right? It's a fraction where the numerator, the denominator, or both contain one or more fractions. Hence, I'm saying it's a fraction. It's a fraction that has a fraction within it. It's a fraction within a fraction. There's a fraction within a fraction. Let me show you. Let's grab just our first example. So this whole expression, it's a fraction. I have a numerator and a denominator. But check, on the numerator, I also have a fraction. And the denominator of the big fraction contains a fraction, right? So when it comes to more complex fractions, you need to start simplifying the smaller fractions. For example, the numerator, you need to simplify. Why? Because there's a fraction there. Here, not much simplification can be done, but we need to start with the numerator because of there's two values adding each other. Like there's an operation between the 2 and the 1 over x. So we're gonna do this. It's gonna be a 2 over 1 plus 1 over x. Why am I dividing the 2 by 1? It's because of this fraction, the 1 over x being a fraction added to 2. We need to change the 2 to a fraction, right? Then here, I'm going to leave it as is. So it's going to be 1 over x squared equal to, then we simplify. I'm adding two fractions. So what do? Butterfly method. The x multiplies that 2. I get a 2x. This 1 multiplies that 1. I get a plus 1. Divided by, then the x multiplies that 1. I'm getting a 1x. Divided by this divide or this division sign, it's this one. Yeah. Then on the denominator, I'm just going to have a 1 over x squared equal to. Then the numerator, the 2x plus 1 divided by x, it's going to get multiplied. We're going to do a tip and times because I have a fraction dividing another fraction. So we're going to tip and times. It's going to be a multiplied by x squared over 1. Then let me continue here. So it's going to be this x squared multiplying this numerator. It's going to be an x squared of 2x plus 1 divided by this 1 multiplies that x. So it's just going to be an x equal to the x squared. Okay, so what's going to happen now is that this x is going to get cancelled by 1x on that x squared, all right? So I'm now going to be left with an x, open bracket, 2x plus 1. This is your final answer, okay? Do not multiply by the x inside the bracket, right? We are simplifying because you multiplying would call for factorization again. So if you multiply, it's not simplified. So just leave it like this, right? Leave it like this as factorized. Now, let's take a second example. So again, this is a fraction, and the numerator also contains what? A fraction, right? The numerator also contains a fraction. So this can be looked as this can be looked at as a complex fraction. So it's going to be a 3 over 1 here, right? Minus x over 1 minus 9 over x. Then here it's going to be x minus 3 divided by a 3 over 1 minus. Then we simplify the numerator first. So what you do with complex fractions, you start off by simplifying the smaller fractions first. So that is why I'm starting with the numerator here. So cross multiplication, I mean butterfly method, x times x, that's x squared, minus 1 times 9, that's 9, divided by x minus 3, equal to 3 over 1 minus, wait a minute, I forgot something here. So it's going to be over this x times that x, it's an x squared. 1 times 9, that's 9. And then this x should multiply that 1. So I'm going to have an x, yes. Then here it's going to be an x minus 3, equal to 3 over 1 minus. And then what we're going to do next is do tip and times. We're going to tip and times the denominator for the bigger fraction. So it's going to be an x squared minus 9 over x. Then we tip and times, it's going to be a 1 over x minus 3. The x minus 3 is divided by 1. It's going to be divided by 1. So it's the same concept I did or applied with the 3 and that x, right? I have a fraction. I have an x subtracting a fraction. So it makes sense to change that x into a fraction by dividing it by 1. The 3 is being subtracted by a fraction. So what you have to do, you divide it by a 1. You convert it to a fraction because you can't subtract you actually can't subtract a number with a fraction, right? In order to do that, in order to subtract the number with a fraction, you have to change the number to a fraction by dividing by 1, right? Okay, so similar thing here, done here. The x minus 3 divide by 1. I'm converting it to a fraction. So that is why when I do the tip and times, about 1 over x minus 3, right? Then we multiply. Then it's 3 over 1. Remember, there's a subtraction sign. Let's start with the multiplication of these two fractions. So it's going to be the 1 multiply the x squared minus 9. It's going to be x squared over x squared minus 9. Then this x multiplies that. It's going to be a x minus 3. But do you see that this is a difference of 2 squares? So we're going to simplify that first. Factorize first. So it's going to be an x minus 3 and an x plus 3 divided by x minus 3. Then this gets cancelled by that. I'm now left with 3 over 1 minus x plus 3 over x. Then we cross multiply. X times 3, that's 3x. 1 times that, it's going to be a minus x plus 3. I'm putting it in bracket because this negative sign is going to affect that x plus 3. Then the x multiplies the 1, gives me an x, equal to, then 3x minus x minus 3 over x equal to, so that 3x minus x gives me a 2x minus 3 over x. So this is my final answer. Now, let's grab one last example. So in this case, I have an x raised to exponent minus 2, a y raised to minus 2, divided by an x raised to minus 1 plus a y raised to minus 1. So in such a case, we cannot work with negative exponents. So we have to change the negative exponents to to be positive. So it's going to be a 1 over x squared. We are applying exponential laws here. 1 over y squared divided by 1 over x plus 1 over y, right? So this is how you make or turn negative exponents to positive exponents, by dividing that term by saying 1 over that term and making the exponent to be positive. Then from Lanage, each bracket has two fractions. So what do? We do a butterfly method. So the y squared is going to get multiplied by the 1, so 1 y squared, minus the x squared times that 1 is going to be a minus x squared over this x squared times that y squared, y squared, x squared, y squared, divided by cross multiply, y, x, xy equal to. Okay, do you see that this is a difference of two squares? We factorize y minus x, y plus y, x plus y, divided by x squared, y squared, multiply by, we change the division sign to a what? To a multiplication sign. Then we tip and times the following fraction. So it's going to be a y plus x lana equal to this times that, this times that. No xy, no y minus x, no x plus y, divided by x squared, y plus x. And then I can see that, okay, this and this are the same, and then this x's will cancel a 1x, this y's will cancel a 1y here. I'm now left with the y minus x over x y. So this is the final answer. Okay, so this is all I have about complex fractions. Okay, so a complex fraction, it's basically a fraction within a fraction, right? So make sure that you deal with the fraction, the smaller fraction inside the bigger fraction first. Then you can solve the bigger fraction after that. Okay, so thanks for tuning in. Thanks for watching, guys. Let's discuss in the comment section nangabuna any questions or any remarks regarding this lesson. Check you out on the next one. Peace.